Howdy, we've got 2011 number 4, and I'm going to be doing part D. In 2011, we have this graph of f. We've got a quarter of a circle, and a line. We're told a couple of points. We can read some other points on the graph. And when you get down to part D, it says to find the average rate of change of f on the interval -4 to 3. The average rate of change is the slope of the secant line, and that's the line connecting the endpoints of that interval. So I'm going to be doing like y2 minus y1 over x2 minus x1, average rate of change, also known as f of b minus f of a all over b minus a. So I have f of 3 minus, and then we're going -4, f of -4 all over the actual x values, 3 minus the other x value, -4. Okay, so on bottom 3 plus 4 is 7, and on top I'm actually going to read these values off the graph, f of 3. So let's head to the graph. When x is 3, y is -3. So f of 3 is -3, and then f of -4, and we're subtracting that. When x is -4, y is -1. So -1 for this spot. Okay, so -3 plus 1 is -2, so we have -2 over 7. That is the average rate of change of the function on the interval -4 to +3. So here's one part of the answer. Now comes the other part. Okay, there is no point C between -4 and 3, not inclusive, for which f prime of C is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem, because the mean value theorem actually says that if a function is continuous and differentiable, then there will be at least one point on the inside of the interval where the average rate of change is equal to the instantaneous rate of change, or the slope of the secant line is equal to the slope of the tangent line. Okay, well, let's see why it's okay for that not to happen. In order to use the mean value theorem, you need the function to be continuous on the closed interval. Let's take a look. Is it continuous? Yeah, looks continuous to me, no breaks, holes, or jumps. But it also has to be differentiable on the open interval. So from -4 not inclusive to +3 not inclusive, it has to be differentiable. And we've got a couple of places where that's an issue. Right here at 0, not differentiable because of the cusp. And a little trickier, but right here at -3, you've got a place where, yeah, that tangent line would be vertical tangent line. So you have two different places where it's not differentiable on that interval. So let's see. This does not contradict the mean value theorem because the mean value theorem does not apply to a non-differentiable function. Yeah. Ooh, good times.